Teaching of fractions using the primary school curriculum guide. Today we'll be focusing on teaching fractions at the Standard 4 level. Standard 4 teachers should teach the addition and subtraction of fractions to whole numbers, addition and subtraction of fractions of same denominators, addition and subtraction of fractions of different denominators, multiplication of proper fractions by whole numbers, division of whole numbers by fractions, and finding the whole given a fraction. Teachers must be encouraged to use the CPA model to teach the children how to add and subtract fractions to whole numbers. Starting with the concrete, teachers can ask the students to model this problem, then state the equivalent to the modeling, that is 2 1/3. Teachers would then be encouraged to do a few more examples before they proceed to the pictorial realm. At the pictorial stage, all the examples that were used in the concrete operations would be displayed. Then the students would make a connection with the questions, the picture, and the answer to come up with their algorithm for adding fractions to whole numbers. At the abstract stage, the students would apply the algorithm for all the questions to enable them to find the answers. Teachers must then provide some worksheets to check for students' understanding. In the subtraction situation, teachers would also adopt the same approach by starting with the concrete and moving to the abstract. Here, subtraction must be seen as the removal of. So when this problem is modeled, we have two wholes and we are expected to remove a third. Teachers can then ask probing questions like, is the whole and the third of the same family? If not, what can we do to make them of the same family? Students, through prior experience, would be able to tell that the whole can be expressed as 3/3. Now that they are of the same family, we can remove one of the third to get the answer. So our answer will be 1 2/3. Teachers should be encouraged to provide a few more examples, at least 3 more examples, before they move on to the pictorial realm. At this stage, the same examples that were used in the concrete stage should be used at this stage so that a connection can be made with the question, picture, and the answer. This is to enable the child to come up with the algorithm for doing the subtraction. And once the algorithm has been derived, they can proceed by using the algorithm to solve the fraction. This here can be done in 2 ways. Here's the first way, and this is the second way. These can be discovered through strategic questioning of the child. Students who would have been exposed to adding and subtracting fractions of same denominator in Standard 3 will be given a second opportunity to learn how it's done the proper way. So the teacher should start with the concrete, and this is done by giving them an example like this and asking the students to model the problem. The students will then provide the answer to the questions that are given using their fraction tiles. Teachers would then provide students with at least 3 more examples before they proceed to the pictorial representation. The pictorial representation would reflect all the examples that they would have done at the concrete stage. so that the student would observe the questions, the picture, and the answer to formulate a pattern. This pattern will form the algorithm for adding fractions of similar denominators. At the abstract stage, students will then apply the algorithm to solve the problems. Fraction is done in a similar manner. Here, we start with the concrete, and the student will model the 3/6 in this example. Having clearly understood that subtraction means the removal of something, in this case 1/6, the student, because of prior experience, would be able to evaluate this problem by simply removing the 6th, resulting in the answer 2/6. If students have forgotten what to do from here onwards, the students can be reminded by the teacher to use the appropriate fraction tiles to reduce this to its lowest form. The teacher then provides the students with a few more of these examples before we move on to the pictorial representation, where the pictorial representation would consist of all the questions that were done in the concrete operation. The students would then make a connection with the pictorial representation and the concrete representation, and by carefully examining the question, picture, and the answer, they will be able to observe a pattern. This pattern would enable them to discover the process used for subtracting fractions of similar denominators. This process is called the algorithm. The algorithm then would be used to evaluate future problems like this. At this stage, students have the prerequisite skills to add fractions of different denominators. Teachers are encouraged to use the same CPA model to do this addition. Starting with the concrete, a problem may be given and the students are to model the problem. By now, students are acquainted with representing fractions using their fraction tiles. They should then recognize that both tiles are not of the same family, and because of that, they use tessellation to get the required amount of 8s that is equivalent to a half. This will then replace the half so that the addition can be formed. Now we have 4/8, which is equivalent to a half, added to 3/8. This would give us 7/8. Teachers are expected to provide a few more examples for students to work on independently, following which they move on to the pictorial realm, where the said problems used at the concrete stage will be represented. The students will then look at the question, picture, and the answer and formulate a pattern. The pattern used would enable the child to come up with the algorithm for adding fractions with different denominators. Here it can be observed that the half was changed to the equivalent form of a half but with a denominator of 8. Then the addition was made. In other words, before the fractions were added, they were brought to the same family. This algorithm that the students have noticed can be used now to solve the problems in an abstract way. Keep in mind that equivalent fractions was already covered, so the students are already acquainted with deriving the equivalent fraction of a half using the algorithm. subtraction should be interpreted as the removal of an item. So that if we had a half minus 3/8, the students will represent this as 1/2, and we are required to remove 3/8 from the 1/2. The student will then see that it is impossible to remove the 3/8 from the half unless you bring the half to its equivalent form with a denominator of 8. The student then use tessellation to get the equivalent form of a half. This would be 4/8. The student would then replace the half with the 4/8 and remove 3 of the 8s. This will give me the answer of 1/8. Again, teachers will be encouraged to give the student a few more examples so that they can be acquainted with how this process is done at the concrete level. The students will now be able to move on to the pictorial realm, where the said questions that were given in the concrete stage are used in the pictorial stage. This is so that the child can make the observation by examining the questions, picture and answer, so that they can derive the algorithm for subtraction. The algorithm here would be make a half an equivalent with a denominator of 8. Then remove the necessary tiles, in this case 3 of the 8s. The algorithm then would be used to do the subtraction. Keeping in mind the students have already determined how to do equivalent fraction by using the algorithm. Here our answer will be 1/8. For the multiplication of fractions, teachers should use a contextual example to initially expose the learners to multiplication. Here's an example. In this example, Sunita bought 3 slices of pizza from Mr. Lambert. This may be represented by 3 actual pizzas that are cut into 8 equal slices, or you can use a replication of the pizza. The shaded part would be the part that Sunita bought. If you notice carefully, you had 3/8 plus 3/8 plus 3/8. When all these are added, this gives me a total of 8/8 plus 1. When we rotate these pizza, we will see that it forms a whole pizza, remaining the 8. So the total amount of pizza that Sunita bought would be 1 whole and an 8. That is 1 and an 8. This must also be replicated in the pictorial representation. Here, exactly what was done at the concrete stage must be done at this stage, so that the student can observe the pattern. Continuous addition is equivalent to multiplication, and so that the student will observe the pattern that if we were to multiply both numerators and both denominators, we will get 9 upon 8,
which is equivalent to 1 and 1/8.
The students then recognize the algorithm for multiplication, and now they can apply the algorithm at the abstract stage, where continuous addition is equivalent to multiplication. And in multiplication, we would recognize the whole number is converted to an improper fraction, that is 3/1. Then we multiply numerator by numerator, denominator by denominator, and convert to a mixed number as the case may be. In general, when multiplying a whole number by a fraction, convert the whole number to its improper equivalent, then multiply numerator by numerator and denominator by denominator. If the product is an improper fraction, convert to a mixed number. Division of fraction can be a difficult concept to grasp if not taught well. However, when we start from the concrete stage, using an example like this, we can interpret division as how many halves can you get from 3 wholes? So that 3 divided by a half is basically asking us how many halves are there in 3 wholes. So if we had 3 wholes replicated using our fraction tiles, we can use tessellation to determine how many halves we can have in 3 wholes. In this case, you can see that there are a total of 6 halves in 3 wholes. Therefore, 3 divided by a half would be equal to 6. Teachers should be encouraged to provide more examples like these before going on to the pictorial realm. Here, we will use the same examples used at the concrete level so that we can make an observation. The total number of pieces that you will have as a result of the division is equivalent to 6. But this is equivalent to multiplying 3 by 2. And therefore, we can see that for the division of fraction, all we have to do is to change the sign from divide to multiply. Then you flip the fraction. This, therefore, will be the algorithm for division of fraction. We can now apply the algorithm in the abstract way for the problem that was given. The students will then use this procedure to do further division of fractions. Finally, we are at the stage where we are to determine the whole given a fraction. Let us take this example. After receiving half of her allowance, Kenny asks her mother to put the remaining portion in the bag. If the remaining amount was $45, what was Kenny's allowance? Okay, now I want to emphasize the importance of not starting off with the algorithm. The students should discover on their own this algorithm. So please do not teach your students to invert and multiply. Rather, have them discover the process. Let's make the discovery using a concrete example, that is bar modeling. Let us use this as the whole. If this is the fraction tile that represents the whole, remember Kenley received a half of her allowance. So this is a half tile, and there are 2 halves in a whole. But the first half was equal to $45. If the first half is equal to $45, then this means that the second half is also $45. So therefore, we can easily see, to determine Kenley's allowance, we could simply multiply 45 times 2. Multiplying 45 by 2 is the same as multiplying 45 by 2 over 1. 2 over 1 is just the improper fraction that is equivalent to 2. And this will give me 90. The students will not immediately see that you need to invert and multiply the number here with one example. So the teachers ought to give several examples. Ideally, teachers should give 3 or more examples. Let me give you another example. This time I will change the fraction to 5/8. Observe the similar process. Here, Kenny received 5/8 of her allowance. If this is the whole, then 5/8 will be 5 of these 1/8. The remaining portion is which she decided to bank. These 3 represent the amount she banked. So this is what she received and this is what she banked. Keep in mind that the amount of money that was banked is $45. This means that 3/8 of the whole is equal to $45. So that 1 of the 8 would be equal to $45 times a third. That is 45 divided by 3. Remember, the whole represents 8/8. So 8/8 would be equal to 45 times 8/3. After you would have done a couple of problems, the student would have seen easily that you had to invert and multiply, so that the whole is the reciprocal of 3/8. In other words, we inverted 3/8 and multiplied by 45. This will give me 120. So Kenley's allowance would be $120. This is the end of the video. Please don't forget to like, share, and subscribe.